Alright, now I'm gonna walk you through the most basic workbenches where you can find in FreeCAD. And the first one is the most important one actually, is a part workbench, and it's basically used for solid and surface modeling based on geometric primitives, right? Also the Boolean operations, and it's really useful for designing 3D basic shapes. And the next one is the part design workbench. This is probably where you're gonna spend most of your time, and this workbench focuses on the parametric and feature-based modeling. You will build a single solid body using 2D sketches and iteratively add additive features and subtractive features such as pads, pockets, fillets, chamfers. And another most important workbench is the sketcher workbench. This is where you design the 2D sketches with precision geometric and dimensional constraints. So it is pretty much the solid foundation before you create the solid 3D model. And next we have the draft workbench. So it is basically used for layouts, annotations, and architectural related work. So basically it allows you to create the basic 2D drafting and the basic 3D constructions. And the next one is the Tech Draw workbench. It converts 3D models into technical drawings with precision dimensions, annotations, and multiple views. Product designers use this workbench to create product catalogs because it is suitable for manufacturing documentations. And the next one is the assembly workbench. This is the most important workbench, I could say, because it used to combine all the multiple parts that you have created in a specific project, and we use those parts and bind them with the joints and other parts, and we apply constraint to simulate real-world movements like the animations and how they fit between the other components with the maximum precision that you could possibly achieve. And now we have constraints. So what exactly are the constraints? So in a CAD, especially in this FreeCAD software, constraints are pretty much like the rules that we apply to the 2D sketches to control the shape, size, and positions and the angles. So we define how sketch elements are related to each other and minimize the potential distortion among them. As you can see, constraints are mainly two types: the geometric constraints and the dimensional constraints. So geometric constraints are referred to as the control relationship, such as the horizontal, vertical, parallel, perpendicular, and concentric, and the coincident. And the dimensional constraints are used to define the exact values such as the length, radius, diameter, and certain angles. As you can see on the figure 6, there is a full constrained 2D sketch, and it is completely in green, and it is a green flag that let us know the sketch is fully constrained. So once you open the software, you're gonna create an empty file. Alright, and now we're gonna have to create a sketch. So we click here. You can see there are 3 planes: XY plane, XZ plane, and YX plane. So I'm actually going to use the XY plane for the demonstration. So click OK. And here's the X and Y plane. Right, so these are the basic tools for sketching. And over here, these are the constraints that we're gonna apply to those sketches we're gonna draw in no time. So let me show you the model in the tab view first. since we have only created a body and a sketch inside, so over here you can change the dimensions in a specific order. We have set standard for the time being, and we're gonna create a centered rectangle, and we take this X and YZ intersection as the reference point to create this centered circle. Alright, once you create the rectangle, you just right click to terminate the command. And now you can see on the left side, the solver message says under constraint there are 2 DRFs, which means 2 degrees of freedom, which means the X and Y axis. This rectangular can move freely along the X and Y axis, just like this. So we have to use constraints to make sure that they will have precise controls. You click this icon over here and select the dimension constraint, and you apply the constraint to one side of the rectangle. You set the length to 50 millimeters, and you can see in the solver message it says under constraint it has reduced by 1 DRF. We're going to apply the same exact constraint to the other side of the rectangle. And you can see in the solver message it says it's now full constrained because you have set the dimensions to both sides of the rectangle. And this gives you the complete freedom to change to make it more scalable. You can change the dimension of this side in 65, and it does not compromise the entire shape. You can see it still shows the full constraint. I'm going to show you how to use other sketching tools such as polyline, because in the previous part we only used the rectangle sketching tool for the constraint demonstration. I'm going to choose line tool and create a random shape just for the sake of demonstration. You can see when you try to connect those joints, the other constraints are showing up. I'm going to connect these lines end to end, just like this. On the left side, as you can see, there is a constraint warning for 8 degrees of freedom. Alright, I'm going to use polyline to draw a shape. And I'm going to connect these lines end to end just like we did in the previous one. Alright, now I'm going to use the circle tool to create a circle over here. Alright. Now you can see there are 18 degrees of freedom under the constraint warnings because we draw so much unconstrained shapes. And this is the arc tool. You can use the arc tool to create smooth and rounded shapes rather than straight lines which have less flexibility. Alright, now I'm gonna use the slot tool. We basically use that tool to create elongated holes for screws as well as sliding parts. You can dynamically scale up or down the shape by dragging these lines. As we work our way through this video series, we're gonna use this pretty much most of the tools to create shapes and 3D models. And impressively, there are 26 degrees of freedom. And I'm gonna show you how to minimize these constraint warnings by introducing constraints to the drawn shapes. For that, I'm gonna use radius constraint and click on the circumference of the circle we have drawn over here. And I'm gonna set the radius to 15 millimeters. And you can see, even though we set the radius of the circle, it has not turned into green, which is the sign of a full constrained shape like we witnessed before in the previous demonstration. So I'm going to use the dimension constraint and set the distance between the XY intersection and the center point of the circle, and we can set it 15 millimeters. And you can see it has now successfully turned into green, which is now the circle is fully constrained. You can actually use this fit all option to picture the whole viewport when things look messy and out of your view angle. And let's get rid of this. So we have come to the end of our second video session. So in this video, you have learned how to draw a fully constrained rectangle as a practical offset for the development of advanced shapes with proper constraints. And also I have demonstrated how to use other sketching tools such as the polyline, arc, circle to help you create shapes. And also we're going to use those tools to draw complex 2D models and transform them into real-world 3D models. So stick around with us. And don't forget to subscribe to our channel and hit the bell icon to get notified on the upcoming videos we have planned to launch.